Hello, welcome to Pragim Technologies. I'm Venkat. This is part 58. In this session, we'll understand what is equals method and the reasons to override that. Now, let's say I have two integer variables, I and j, both carrying value 10. So int I equals 10 and j equals 10. And let's say I want to check if these values are equal, and there are two ways to do that. One is I equal to j, so obviously we are using the comparison operator, and the other way to check that is to actually use I, and look at that, when I say dot, you see that there is a method called equals. Okay, so where is that equals method coming from? Okay, now we know that within .NET every type directly or indirectly inherits from system.object, and if you look at system.object, so if you look at the system.object type and I right click and select go to definition, you see that there is an equals method. Okay, so and if you observe, it's a virtual method, meaning it has some default implementation. Okay, so what is the use of this equals method? It basically checks the equality of values. For example, here I is carrying a value of 10, j is carrying a value of 10. So are those values equal? If they are, then that method returns true. And look at this, it's virtual, meaning it has a default implementation in the system.object class. And if the derived types want to override that, that's possible. Okay, but for value types, we don't have to necessarily do that. Okay, understand that a bit more. So, but understand, for the time being, this equals method is actually coming from system.object, and keep in mind system.object actually provides, the equals method, get hash code, and then toString method, which we have seen, and as well get type. So if you look at this equals, get type, get hash code, and toString, all these four methods actually will be present on any type within .NET Framework, because every type directly or indirectly inherits from system.object. Okay, so now if I want to compare the values of I to j, I can use the comparison operator. I can also use the equals method. Now look at this. When we run this, okay, both of them returns true. Okay, I is equal to j, I dot equals j, both of them returns true. And along the same lines, let's say for example enums, we know they are value types. Let's say I have an enum called direction, for example. So public enum, and let's say direction is the enum, and obviously we know the directions east, west, north, and south. So let's say east equals 1, west equals 2, north equals 3, and south equals 4. Okay, now I can create a variable of type direction enum. Let's say direction. Let's call this direction1. Let's say that's east. And along the same lines, let's create another direction, and let's say this is direction2. Now, just like how you're comparing, integer types, you can also compare enums in spite of their underlying values. You know, we know that the underlying values for these enums by default is an integer. If you don't know what enums are and when we should be using enums, we have a video recorded on that. So I strongly suggest, checking that video first. So direction1 dot equals direction2. Okay, so now if we run, since enum is also value type and values, basically equal to operator and equals method, both of them returns true because they are the same. But on the other hand, if you just say, okay, instead of east, let's say west, and obviously both of them now should actually return false. So both of them return false, and that makes sense. Now this equals and the equals method and equal to operator, both of them work as expected if these are simple types. But however, when it comes to reference types, let's say for example I have a class. Okay, let's say I have a class called customer, and this class has got two public properties. Let's say public string maybe first name. Let's make this an auto implemented property with a default get and set accessors, and along the same lines let's have last name. Alright, a very simple class that we have here. Now let's create an instance of this customer class. So customer C1 is equal to new customer, and let's say C1 dot first name is equal to Simon, and maybe C1 dot name is equal to 10. Alright, and then let's create another customer object, customer C2, but I'm not going to new up this, but I'm just going to say, okay, C2 is equal to C1. So now with this code you should have understood already, there are two object variables here, but the object itself is one. Okay, if you're not sure about the object reference variables and the objects, the difference between them, I strongly encourage you to check the video on classes introduction in this series. Okay, now if you look at this, in this example we have two object variables C1 and C2. Okay, these two reside on the stack, whereas the object itself, the customer object, is one. Okay, so both of these reference variables are pointing to that object. Okay, so we have two different object reference variables, but the object itself is one. Okay, now let's see how these are going to work. So when I say C1 is to C2, and similarly C1 equals 2. Now if you look at this technically, when we run, both of them returns true, and that makes sense because actually in C sharp, when we are comparing types, two things that we were talking about equality here. One is the reference equality. Are the object reference variables pointing to the same object? That is, the same references. Are they pointing to the same object? In that case, if they are pointing to the same object, then we say the references are equal. And obviously, when references are equal, the values will also tend to be equal because it's the same object. Okay, now whether you say C1 dot first name or C2 dot first name, you end up getting Simon. Why? Because both of them are actually pointing to the same object. So when two object reference variables are pointing to the same object, operations on one variable will affect the values contained by another variable. Why? Because they point to the same object. Okay, so the point to keep in mind here is, if two reference variables point to the same object, we have reference equality there, and at the same time values equality as well, because the first and last name of C1 is the same as first and last name of C2. They both, the first name is Simon, the last name is Tan. So when references are equal, the values will automatically become equal if they point to the same object. Okay, so here it returns true in both the cases, which is very much valid. But on the other hand, let's say I'm going to create another instance of this, another new customer, but this time what I'm going to do is I'm creating another new object altogether. Okay, now C1 and C2 are pointing to two different objects together. So obviously they are not pointing to the same object. They are not referring to the same object. So the reference equality, which is this double equals, will be false. But if you look at the values that are carried by C1, Simon is the first name, Tan is the last name. Similarly for C2, Simon is the first name, Tan is the last name. Okay, so the value equality is there, but there is no reference equality. Why? Because these two reference variables are now pointing to different objects on the heap. Okay, so the point to keep in mind, if reference equality is true, then obviously the value equality will also become true. But on the other hand, value equality does not guarantee reference equality. And remember, when it comes to reference types, by default, the double equals comparison operator, gives us reference equality, whereas the equals method, should be giving the value equality. But now when I run, both the reference equality and value equality returns false, which doesn't make sense here. Because why? If you look at C2, the first and last name are same as that of first and last name of C1. Okay, so the value equality should be true. But reference equality is false, and that makes sense because they are two different references to objects. Alright, so this is the reason when we actually have to override the equals method to ensure we get what we expect. Okay, and the reason why we get false is that because of the default implementation, because the default implementation that's coming from the base class doesn't know what properties to check for the equality. Okay, that's when we will override that inherited virtual equals method from system.object. So let's see how to override that, and it's very simple to override. So override, what we want to override the equals method, and look at that. The moment I select that, I get the signature of the method. Now what we need to do, first of all, look at this. What we are passing in is the object type. We are not passing in the customer object. If you remember, this this equals method is actually coming from system.object type. Okay, so system.object, if you look at the signature in system.object, what we are passing in here an object type. So that the signature has to match the signature. Because why? We are overriding that. Okay, so now the passed in parameter to compare should not be null. So what you need to check, so if the passed in parameter, if it is null, then are they equal? No, they are not equal. So what should you do? You should return false. And similarly, if they don't pass in customer object, okay, or any type that is derived from customer object, if they don't pass in that, then it doesn't make sense to compare. You cannot compare a customer object's first name with maybe an employee name's employee ID. Okay, but you have to compare two customer objects together. Okay, it can be customer type, or it can be any other type derived from customer class. Because let's say, for example, you have a customer class. From the customer class there might be banking customer or corporate customer and retail customer. Okay, so inherited types can also be passed in, because why? Inherited types are again your specialized types of your base type. Okay, again, if you're not sure about inheritance, please check the video tutorial on inheritance in this video series. Okay, so another check that we need to pass in, if the passed in object is not the customer type, or if it's not an inherited member of the customer type, then we want to return false. Why? Because you cannot compare it otherwise. Okay, so if that object is customer, if that's customer, fine. But if it is not customer, then what we need to do, we need to basically return false. So if the passed in object cannot be typecasted to customer, or if it's not customer type, then just return false. And finally, what we need to check, the passed in object's first and last name should be equal to this instance of first and last name. So we want to return this dot first name should be equal to passed in object's first name. But if you look at that, passed in object doesn't have first name property. Why? Because that is system.object. It's the base type. So what we need to do, we need to typecast this to customer type. Okay, if we are not able to do this, then it would have already returned false. So we would never get to this line. So customer.first name. So they should be equal, and along the same lines the last name should also be equal. So what you can do, just copy that. That's it. So if they are equal, then return true, otherwise return false. Okay, so now if we run this for the value equality, since we have overridden that, it's still returning false. Let's see why. Okay, we have Simon, Tan, both of the values are equal. Let's look at the implementation. Okay, the first name should be equal to the first name of the passed in object. Similarly, the last name should be equal to the passed in last name. So it looks fine. But for some reason, we are still getting false. So let's see why. Let's put a breakpoint and let's debug that. Okay, let's put a breakpoint against this one. Run this. Okay, so we got there. Let's press F11. So we get into the override. So object is not null because we passed in the customer object. So let's press F10. So object is of type customer. So obviously we don't get that. And look at this. This dot first name. What's the first name? Simon. And similarly the objects. Oh, look at that. The passed in object's first name property is null. Let us see why it is null. Okay, look at that. That's the problem. Here c1.firstname, because we copy pasted this code here. That's why c1.firstname and c1.lastname. It should be c2.firstname and c2.lastname. So let's correct that. So this is how, when you copy paste code, you should be extremely cautious. These are the blunders of copy paste. So now if we run that, we should get the value equality. However, there's a slight issue here. The issue is if it's that green squiggly within .NET Framework, if it's a green squiggly, then it's a not an error. And if you look at the one, okay, the customer class overrides object.equals to override object. If you look at system.object class, it has equals method and at the same time it has get hash code. Okay, so if you are overriding equals, it's also recommended that you override get hash code. Otherwise, the hash codes are not guaranteed to be unique. That's why it's a very good practice to actually override the get hash code method as well. And it's very simple to override that. So let's see how to override the get hash code that we get rid of this warning. And to do that, override and then press space and you have that get hash code method. Just select that and you get the syntax of the method. And what we need to do here is return the hash code. If you look at this property, this class, it has got two properties, first and last name. So return the hash properties and that should be it. So return this get hash code and that with this dot last name dot get hash code. That's it. So now if you rebuild your solution, you should have got rid of that warning. So that's gone now. You don't have any warning now. And obviously you run this, for the reference equality, we get false, but for value equality, we get true. So obviously, if you want the objects to be comparable in a proper way, you have to override the equals method. And when you're overriding the equals method, keep in mind you have to check if the passed in object is null, and if you can typecast the object to the type that you are comparing against. In our case, this is customer. So we should be in a position to typecast that to be of type customer. And then compare the properties that you want to check for the equality and return true or false depending on equality. All right. On this slide, you can find resources for ASP.NET and C# interview questions. That's it for today. Thank you for listening. Have a great day.